Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back to this TV Learning Series program. I'll be with you in these 30 minutes to come, and I'm teacher Patrick. I'll be with the Senior 6 class, and we are still looking at Unit 4 and 5. No, we had finished Unit 4, so we are still on Unit 5, but I thought it much necessary to at least have maybe some questions that we are going to answer together, and then we assess ourselves so far, what we have covered and what we can remember. As you are aware, when we are reading either the notes that we have prepared, we have to assess ourselves to find how much we have retained through the process of learning. Once you don't have the question to answer, you may not be aware or you may not know how much you still remember. So questions or continuous assessment exercises along the lessons or along the process of learning is very much important. So that's why I thought of doing some small, simple questions, and then we just continue together. So without wasting a lot of time, we are just starting with question number 1. And that question number 1 is reading. Some reactions of benzene can be summarized in a flow sheet below. This is the flow sheet that we are talking about. Part A, we are supposed to name substances A to F. And then B, Roman 1, the reactions to form E is here, as you can see. And nitrobenzene are electrophilic substitutions. The reactions to form E and nitrobenzene are electrophilic substitution reactions. Give the formula and charge of the electrophile in each reaction. In the reaction to form, that is part 2 of B, in the reaction to form nitrobenzene, it is important to keep temperatures below 55. Suggest a reason for this. What would be the reason for keeping the temperatures below 55 degrees Celsius? State the conditions, that is part C, Roman 1. State the conditions for the reaction to form A. This is A from the benzene. So this is the benzene we are talking about. Rule 2, benzene reacts with chlorine to form 1, 2, 3, 4, 5, 6 hexachlorohexane, which is an important insecticide. Write a balanced equation for this reaction. So those are some of the questions for number 1. So we're going straight to answer. So we're supposed to name substances A to F. So we start with substance A. So these are solutions that we have to look at. So the solutions that we'll come up with. What is A? We start with A. Which compound is this? We give the names. So this one doesn't have the bonds inside. So it means it has single bonds all throughout, and therefore this is an alkane. And remember, because it is cyclic, it is in a ring form, then it is called cyclohexane. 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 So that is A. We're supposed to name A to F, name substances. So we have A. B, what is this B? So we're supposed to name them what? So this is the reagent. So this is B. What is B? C, A, and F. So we're supposed to give the answers for those parts. So where is part B? Part B is this one. So this is the reagent that is used to hydrogenate benzene. So that is hydrogen gas. This is hydrogen gas. C, we have C here, so this is the benzene forming bromobenzene. So what is this C and what is D? So we are reacting there with, it has to be bromine, that is either, so we can either write it in. So you have to pay attention when you don't know the formula of the compound and you are asked to name, please give the name, because you may write the formula in a wrong in a wrong way. So you need to give the name to be precise. A, B, C, you're supposed to go to D instead of E. That is not proper alphabetic. C, this is D, E, and then F. D is where? So D, that must be an halogen carrier, which is used as a catalyst, and it has to be a Lewis acid. So here we can use either iron 3 bromide or iron 3 bromide or any other halogen carrier, not necessarily iron 3 bromide, iron 3 bromide. This must be 3. So we go to part E. Where is E? So they need the name of this one, which will be bromobenzene. Bromobenzene. F, where is F? So benzene goes to nitrobenzene. So what is this F? So F is likely to be a combination of reagents. So here you have concentrated nitric acid in presence of concentrated sulfuric acid. So this one is acting as a nitrating agent. The reactions to form E and nitrobenzene are electrophilic substitutions. Give the formula, so give the formula, that is part B. Part B, Roman 1. What is the formula of that species? The formula of the charge of the electrophile in this case. So the electrophile, because we see the substitution, this is bromine. So the bromine has to be substituted. So this has to be, this is the formula of the formula of the electrophile. So the charge on the electrophile has to be positively charged. Electrophiles are positively charged always. In the reaction to form nitrobenzene, this is the reaction, it is important to keep the temperatures below 55 degrees. Why? I suggest the reason for this. When the temperatures go beyond 55, the nitration continues and it will be substituted. Position number 2, 4, and 6. So to prevent further substitution of nitronium ions, the temperatures have to be kept below 55. So this is to prevent, that is Roman 2, to prevent further substitution of nitronium ion. So that is the reason why the temperatures have to be kept below 55 degrees. State the conditions for the reaction to form A from benzene. What are the conditions? So the conditions, the catalyst has to be present. That is C, Roman 1. So you need the catalyst. That is one condition. And what is the catalyst that is used? This is nickel. Nickel catalyst, or you can use either palladium or even platinum can be used. So that is the condition for the reaction for A to form. So you have the catalyst, and then you have the temperatures between. So the temperatures between 150 degrees Celsius to 200 degrees Celsius. Those are the conditions for this reaction to occur. Benzene reacts with the chlorine to form this. So the benzene reacts with chlorine to form 1, 2, 3, 4, and then cyclohexane, and which is an important exercise. We asked to write the balanced equation for this reaction. So the reaction that forms 1, 2, 3, 4. So you have benzene. This is benzene. This is the structure of the benzene. You always need to remember that delocalization, the pi system. So you need to put them down. And this one is the simple one. So that is benzene. It reacts with chlorine. And it reacts with chlorine to form, they said 1, 2, 3. So this is chlorine. This is another chlorine. 2, 3. This is another chlorine. This is another one. This is another chlorine. And this is another one. It is a cyclohexane. So if it is a cycle, that is an alkane. So you don't need the delocalized pi system there because it is an alkane with carbon atoms attached to single, they are joined to other carbon atoms with a single bond. So these, how many are these chlorine? 1, 2, 3, 4, 5, 6. And you have these 2. So you need to make them, because it said it has to be balanced. So how do we balance? 3 chlorine atoms. So we have the number of carbon atoms and the hydrogen atoms will be the same, because here we have each carbon atom, those are 5, and we have 6. And then we have each here, we also have 6 hydrogen atoms and 6 hydrogen atoms. So the equation will be balanced in that form. So let's go to question number 2, which is the scheme below shows some reactions starting with methyl benzene, because we have finished methyl benzene. Give reagents and conditions used to carry out reaction steps 1, 2, 3. So this is reaction step number 1. This is number 2, it's over here, and this is number 3 over there. So give the reagents. Let's start with step number 1. So that is number 2. We are asked to give the reagents and conditions. Step number 1. We will start with the reagents, and then we add on conditions. That is step number 1. So we are seeing this is methyl benzene forming, that is chloromethyl benzene over here. So the chlorine is added over there. So that means you have, so that it is, the reagent here is chlorine. So yes, this is chlorine gas. And what are the conditions? So we see the substitution there. The substitution is taking place over here. We have CH3, and here we have CH2 chlorine over there. So this is CH3, so there is a substitution. So what are the conditions for this? If you remember some of the reactions of methyl benzene, so as we are looking at this, you need to recall some of the reactions of methyl benzene. So the conditions here has to be ultraviolet light, or which is either UV or sometimes heat that can be used. Those are the conditions. Step number 2, remember I have to, step number 2. So we need reagents and then conditions. What are the reagents for step number 2? Number 2 is here. So we are seeing OH here substituting this. So the reaction is only taking place on that one and this. So you see the chlorine being substituted by the OH. So what does that mean? That is a nucleophilic substitution. So that the reagent here is either using aqueous sodium hydroxide, or sodium hydroxide solution, or aqueous sodium hydroxide. And here we can either use the heat or, in most cases, using the word reflux. So that is the condition. Step number 3. So we go to step number 3, then look at the reagents, and then conditions. Step number 3, so where is the step number 3? It is over here. So what is happening? This is methyl benzene, nothing changing here, but we see a nitro group being attached on this carbon number 4 of the methyl benzene. So what is happening? That is a nitration reaction. So in the step number 3, the reagents that we are using over here is it is concentrated nitric acid. Concentrated nitric acid. The condition here is it has to be concentrated sulfuric acid. And therefore, even remember the temperatures. This is methyl benzene. We said this one takes place at around 30 degrees Celsius. So the temperatures are lower compared to nitrating the benzene. Benzene is around 50. Why? Because this methyl benzene is electron donating, so the nitration becomes much easier. What type of reaction is step 4? So this is step number 4. What is happening here? Nitro changing to amine. Probably we have not looked at, because we have not looked at the aromatic amines, but this is a reduction reaction. That's part B. This was part A. So this is a reduction reaction. Very soon we'll also talk about that one. Give the structural formula of compound A. What is compound? This is compound A here. So where methyl benzene is reacting with the chlorine in presence of iron 3 chloride. So the A, if we are talking about A, that is, say, the structural formula of A. So we see the substitution taking place. So we had a methyl group here. So this is either chlorine will be substituted there, or so any one of these with chlorine, because the methyl group is electron donating, has positive inductive effect. So that means it directs other substituents to position number 2 and position number 4, the ortho and para positions, remember. So that is structure of A, if you are talking about. So what is the name of the mechanism involved in step 1? So we have step 1 here. What is the name of the mechanism here? Do you still remember that? I hope so. So good. This is in step 1. Step 1, is that step 1? Yeah. The mechanism here, we said chlorine is being added there. So this is free radical substitution. Free radical substitution mechanism. So what is the name? Step 2. What is that? Step 2? What is step 2? Step 2 is over here. So what is the name? This is step 2. So we have nucleophilic substitution. substitution. That is the name of because this is the nucleophile. This OH is acting as a nucleophile, and it is substituting the chlorine over there. So let's look at the last, probably, that could be the last question that we'll be able to answer. A sulfonic acid, this is the sulfonic acid, can be synthesized from methylbenzene according to the scheme below. This is the sulfonic acid mentioned, which is the same as this. And it can be synthesized from methylbenzene from here through the steps that is indicated. Step number 1, step number 2, step number 3. What type of reaction is step number 2 here? This is nitration. So this is number 3. What type of reaction? This is a nitration reaction. Nitration reaction. Or sometimes you can say electrophilic substitution. Or maybe you can say electrophilic substitution. But this one is more general, electrophilic substitution. So when you say electrophilic substitution, you are also correct, but you are becoming more general. So it is nitration, but to be precise. But even electrophilic substitution, you will be correct. For each of the steps 1 and 2, state the reagents. This is step 1. We have mentioned these reagents. So you see, the questions somehow repeat themselves. The reagents here and the reagents here. So what is happening here and what is happening? So we see the nitronium ion substituting the methyl on position number 2. And we have the nitronium ion. Now we have another substitution, number 4. So we have what are the reagents. For each of the steps, we need the reagents. That is part B. We need the reagents for step number 1. So the reagents we have mentioned before, step number 1, we'll have concentrated sulfuric acid, concentrated nitric acid first, and even concentrated sulfuric acid used as a reagent, though it is also used as a reaction. Dilute nitric acid can also be used. Step number 2, this is step number 2. So here, in step number 2, you'll have either fuming sulfuric acid, or you can say concentrated sulfuric acid. Any one of these that you give is also correct. And conditions needed to carry each out of the reaction. So each of the reaction, that is 1 and 2. So you need the conditions for those reactions. So you need step number 1, you need to indicate the conditions, and step number 2, also the conditions. What are the conditions for step number 1 and 2? So here, what is the condition? Temperatures about, in step number 1, we need temperatures of about 30 degrees Celsius. And presence of the acid is also important, but the most important here, so sulfuric acid can also be used as a reagent. Step number 2, where we have here, the conditions here that we have here, we can say even heat, just heat. Maybe below 80 degrees Celsius. Temperatures below 80 degrees Celsius. Outline a mechanism for reaction in step 2. So the mechanism for reaction in step 2. So we need the mechanism for that. Where in step 2, if you look at the reaction, we are moving from methylbenzene, which is CH3 with the nitro, and we are moving to CH3, nitro, and then sulfonic acid. So this is a sulfonating agent. So we need to add that sulfonating agent. So what happens here, the sulfuric acid, this is the sulfuric acid. Remember, this one has two, they protonate each other to produce, this is the sulfuric acid. So this one has to be protonated, has to remove the hydrogen ion, and then this one has to form. So you have HOS with oxygen with the hydrogen atoms. So this one has been protonated here, so it has been removed. So this one moves away, and then you remain with HOS with, this has to be a positive charge, and therefore this is a this is the nucleophile, electrophile, which would have to, so the water is eliminated. This nucleophile attacks the benzene ring. So how does it attack the benzene ring? So you'll have, this is the nitronium ion, CH3. So this one attacks the benzene ring. S, we can just put it in this way. So this one attacks the benzene ring. And it has to be position number 4. So this one moves like this. So this one substitutes the hydrogen that is attached on this carbon atom. So you have a hydrogen here, and then you have, this is a positive charge, you have SO3H, and therefore the hydrogen atom, remember you have a methyl group here and a nitronium ion here. So this hydrogen is eliminated. So you remain with your compound that has been formed, SO3 with NO2 and CH3, then plus the hydrogen, which combines with this one, because it combines with the, you see this one has been moved, 1, 2, 3, 4. So it combines with SO4H. So both of these one will produce sulfuric acid, which is used as a catalyst. So those are some of the questions that we are able to answer for this time. And of course, I will not leave the exercise, because we have been answering the questions. So there is no need of leaving the exercise behind. So I hope you've been following, and I've not even removed anything. So I hope you have put down whatever we were writing properly in your notebooks, so that you can be able to make the references. Thank you so much for being with me in this lesson. I hope we'll be together in the next lesson, which will be coming in the next coming lesson series. See you and have a good day. Bye.